will help you to understand the like pattern of quiz 2 and weightage of quiz 2. The mock you have seen, right? Anybody of you have seen the mock as of now?
No, sir.
Okay. So, okay, don't, okay, no problem. So just go through once and try to attempt, because mock, I mean, you will get the similar pattern of the question in the your quiz 2 exam. Okay. So it will help you if you are attempting the mock. Okay. Maybe you have I mean, we have sent one announcement also regarding the mock. Okay. Okay. So let's start the session. So just one hint or important, you can say, uh, instructions from our side. So just try to attempt the mock. It will give you some idea. I mean you will get a more or less similar pattern in quiz 2 exam, and more or less the questions from the same week. Okay. I mean, anyway, questions will be different there, but you will find the same difficulty level, similar difficulty level in your question exam. Also, I have uploaded the week-wise weightage on the Discord, which you can see. Okay, let me share my screen. We'll go the concept wise, and we'll mainly focus on the important topics of week 7 and week 8 as per point of question exam. Okay. If at any point you are facing difficulty, do let me know. We'll discuss the things. Okay. Fine. So major topic is from week 7 and week 8. Okay. Mainly topics is are so what about sample mean? Okay. Then sample variance and weak law of large number. Then its short form is WLLN. Then moment generating function. Short form for the same is MGF. Okay. And central limit theorem, which is very important uh, thing of the statistic world actually. CLT plays a very important role in statistics world. Okay. Fine. So okay, so before going to sample mean, right? So there is one terminology called IID. Okay, before starting the sample mean and all, I will focus some terminology, then we'll move to the sample mean and sample variance and all. So what is the full form of IID? Anyone?
Independent and identically distributed.
Independently and identically distributed, right? That is the full form
Yes.
of IID. But any one of you can tell me why we are taking the IID samples? Is there any reason behind that?
Sir, we are assuming.
That's okay. We are assuming IID samples, or in
For
real
simplifying
life,
calculations, I
we
guess.
are trying to take IID samples. But why? Is there any idea? Is there any reason behind that?
Sir, because it becomes very easy.
In terms
Calculation.
of what?
Because each random variable has same probability.
That's the meaning of identical, right? But why we are taking IID? My question is that.
To follow, sir, to study the same nature of this
Correct. Correct.
random
Some sort.
variable.
Suppose, yeah. For example, yeah, say, correct. Suppose you, as an analyst, you want to do some analysis on rose plant. Let's say you are interested to know the characteristics of, I mean, how much time a leaf of a rose plant is taking, something like that. Any your objective can be different. Suppose your objective is something like that. So there are two kind of samples. Suppose sample one is you are selecting as, let's say, you you took a sample of, let's say, lotus plant, and you took one sample of, let's say, lily and some other. Or sample two, suppose you took a sample from, I mean, from a rose plant, then sample from another rose plant, and sample from another rose plant, something like that. And all are independent. Okay. So which sample you will prefer?
Second one, sir.
Second one. Why? Because it will give you the good result about your analysis, right? Correct? So that's why this is meaning of identical. If you see, okay, it should be from the, I mean, all items in the samples are taken from the same probability distribution. That is the meaning of identical. Independent, it should be independent. Otherwise, there is dependency, then you will get the result, but your result, I mean, there will be some biasness in your result, right? That's not a correct result. Yes or no? Fine. So identically distributed means we write down. Okay, let me write down that second place. Okay. So identically distributed means all the items in the samples are taken from the same probability distribution. That is the something meaning of identically distributed. And independence means what? Anyone? They are not connected to each other, right? In any way. Yes or no? That is the something meaning of independence, right? To each other in any way. Then I will say they are independent. Correct? This terminology is okay. Why we are taking IID samples and all? Fine. Yes, no? Any thought?
Yes, sir.
Yes,
Fine.
sir.
Yeah, great. Okay, so if you see, suppose I'm taking, let me come to a very simple example. I'm saying x1, x2 up to xn. These are something we are taking IID samples from x. And this is one of the distribution. Let's say I'm saying this axis follows Bernoulli P. And all these are from Bernoulli P. So there is one terminology called sampling instances. So sampling instances means, what is the meaning of this sampling instances? For example, see, this x1 is Bernoulli P. It can take value 0 or 1. Similarly, x2 can take 0 and 1 and up to 0 up to xn. Correct? Yes or no? So sampling instances means we are normally denoting with small x1, small x2 up to small xn. For example, you are taking some, let's say 5, x1, x2, let's say x5. These are from Bernoulli P. So one sampling instance can be 0, 0, 1, 1, 0. Another, so these are just value of small x1, small x2, small x3, small x4. Why we are writing in general small x1, small? Because it can take any value, right? 0, 0, 1, 1. See, this is sampling instance 1. Another sampling instance can be, it can be 1, 0, 1, 1, something 0. Right? So this is just a terminology for sampling instances here. Okay. Is this fine?
Yes, sir.
Okay. So let's move to the our main content where we have to focus, called the sample mean. Okay. So it's I think this is a very simple definition, but let's focus. Let's just discuss. So sample mean is nothing. Suppose I'm saying let x1, x2 up to xn all are IID samples from a distribution x. Okay. That distribution can be any distribution. IID samples from a distribution x. Okay. And this x distribution x has the mean mu. Okay. And I'm saying variance sigma x square. Okay. So I'm talking about this x means I'm talking about this Bernoulli P. So this Bernoulli P will be having mean as P, variance will be P into 1 minus P, right? Okay. So
Yes,
this
sir.
next to xn are taken from a distribution x. This distribution x can be anything, can be Bernoulli, binomial, Poisson, anything, but we are generalizing here. So sample mean is nothing but we are defining sample mean, nothing but I can define x1 plus x2 plus up to xn divided by n. This is something we are defining sample mean. Yes or no?
Yes, sir.
So this is the sample mean. Actually, can you tell me this sample mean is a random variable or constant?
Random variable.
Why random variable?
So because different samplings will have different samples.
Correct. So it is actually a random variable, because if you take another sampling instance, right, you will get the different way. Yes or no? For example, let's see the example. Okay. For example, I'm saying, let's say x1, x2 up to, let's say I'm just taking 10 samples. These are from IID, let's say binomial for our simplicity. I'm saying these are from IID binomial 3 comma half. Okay. So what is the, okay, with mean, so what is the expectation of x here?
NP
What is the n?
10.
N is 10 or 3? Here n is n, sorry, 3. This is n, this is p. These all sample are taken from this distribution. So np, so it will be 3 into half, then this is nothing but 1.5. Okay. Got it? Okay. So let's take the very first sampling. I'm just taking some sampling. Okay. So this can be, yes.
Sir, what is here x1 and x2?
These are the sample you are taking from this distribution. Okay, this x1, you have collected x1 with the probability distribution and with the, let's say, from x, and that x is binomial distribution. Fine. So this
Sir,
x1, see, this x1 is taken from this binomial distribution. For example, here rose plant you can see, I have taken this sample from rose plant. I have taken this sample from the distribution of rose plant. Got it?
okay.
Yeah. The same thing, x1, x2, x10 are, these are the IIT samples from binomial 3 comma half. Okay, means this x1 will have the property of binomial 3 comma half. This x2 again will have the, it is followed as binomial 3 comma half. That is the meaning. Got it?
Okay.
Okay. So suppose I have taken one sampling instance as 300, 112, something, let's say 1021, for example. Okay. 10. Okay. Means this x1 is taking value 3 here. X2 is taking 0. X3 is taking 1. Similarly, x10 is taking 1. Okay. Since it's a binomial 3 comma half, so any of the xi can take value 0, 1, 2, 3. Yes or no? As per the property of binomial. Yes or no? Are you getting what I'm trying to say here?
Yes, sir.
Yes, sir.
Yeah. So what will the first sample mean here? I mean, first sample mean, I mean the sample mean of this values. It will be 3 plus 0 plus 0. Anyone can sum up and tell me the values? 0 plus 2 plus 1 divided by 10. It will be 3, 5, 2, 7, 11, right? 11 by 10, which is nothing but 1.1. Correct? Suppose with the same property, suppose you have collected second sampling instance, and that sampling instance, for example, let's say it's a 2, 2, 1, something like that, and again 1, let's say 3, 2, and I'm saying, let's say 0, 0, 2. 10 is there, right? 9. 2, 2, 4, 2, 6, 2, 8, 2, 9, right? 9 is there, correct? Okay, let's make it
Yes.
one another 0. So what will the mean here, sample mean? It will be 2 plus 2 plus 1 plus 1 plus 3 plus
13 by 10.
it's a 13, right? So 13 by
Yes.
10 is nothing but here 1.3, right? So as you can see,
Yes.
value is different, right? For different sampling instances, we are getting different sample mean. Yes or no? Correct. So here we'll say sample mean, that means x bar is also a random variable. Is this fine?
Yes, sir.
Correct. Now, I mean, the same in the similar way, if you take another sampling instance, you will get the different values of uh, uh, sample mean. Now, another thing is called expected value. So this is something you can keep in mind. I mean, this is something important as point of quiz 2. So expected value and variance of x bar. How will you compute the n equal to 3? Yes, n equal to 3 there. Okay, so here not, see, while calculating the mean, it's not n equal to 3. See, n equal to 3 means I'm talking about binomial. Here it's simply means x1 is from binomial distribution 3 comma half. x2 is also follows binomial distribution 3 comma half. That is the something. Okay. Now, what is the expected value and variance of your sample mean? Okay, so let's talk in general. Suppose I'm saying x1, x2 up to xn. These are IID. I mean, these are IID distributed. I mean, IID samples. Okay, from x in a distribution x. Okay, and this x has mean, mu, and variance sigma square. Okay, now. So what is the expectancy? This is the x bar is the random variable, right? If it is a random variable, I can find the expectation of this and variance of this. Yes or no?
Yes, sir.
And suppose x bar is defined as a summation of x size divided by n. Then main property is what is the expectation of x bar?
Mu itself.
Okay. So expectation of x bar is mu, and variance of x bar will be
Sigma
sigma
square by
square
n.
by n. Okay, so do you need the derivation behind this, or is it fine how we are getting this?
Fine, sir. Fine.
But the derivation is not important, right?
No, derivation is not important as exam point of view. If you want how it will come, then I can explain for a minute. Let me give
Not
you idea.
really also derivations are not important. The result is important.
Result is important, but you should know the reason behind it, how we are getting. Okay, let me just
Sir.
give you some sort of rough idea. Okay, so what is the expectation of x bar? Expectation of x bar means I can write expectation of x1 plus x2 up to xn divided by n, right? And we know expectation of ax is nothing but what? A times expectation of x. Yes or no? By the property, correct? So 1 by n I can take outside, and I can do expectation of x1 plus expectation of x2 plus up to expectation of xn. Yes or no?
Yes, sir.
Correct. And expectation of each xi is mu. So it will be mu plus mu up to n times mu.
N will
So
be
we are
n.
getting the numerator n times mu divided by n. N will get cancelled out. So we got expectation of x bar as a mu. So this is something you can keep in your mind. I mean, okay, this is important. You can make some 3-star, 5-star. It's important.
Sir, one, two, clear.
If x1, x2, xn are there with some distribution, with follow some distribution with mean, mu, and variance, then expectation of x bar is this, variance of x bar is will be this. Okay. Now, how we are getting the variance? Let me just do.
Sir, one, two.
Sorry.
Sir,
Sir, but
I'm asking that x1 and all are expectations of the samplings.
See, these are the random variables. Okay, these are the different samples from x, and this x is nothing but have mean, mu, and variance sigma square. And these are the IID. If IID means expectation and variances will be same. Okay, fine.
Yes, sir.
Okay, yeah. So in
sir,
variance,
what will be the expected value of s means s x1 plus x2 x without dividing it by n?
tell
It
me,
will end.
tell me
It
how
will be n
what
times
it should be.
And mu, sir.
n times mu.
That's all. Yeah, we have to just apply the expectation property, right?
Okay. Yeah.
Okay. Tell me what I will get from here.
1
What?
upon n square.
Yes,
1 upon
because
n square.
we know variance of ax, where a is a constant, it will be a square variance of x, right? So it will be 1 upon n square, and we know xi's are IID, then I can separate the variances, yes or no? I can write variance of x1 plus variance of
Yes, sir.
x2 plus up to variance of xn, right? If it's not IID, then we can't write, okay? It will be 1 by n square, and variances for each xi is sigma square up to sigma square. In the numerator we'll get n times sigma square divided by n square, because x sigma square we are writing n times, it will get cancelled out. So we are getting variance of x bar as a sigma square by n. Is this clear now? Okay, so by this
Yes.
property, what you can say by seeing this, I can simply say if I have more samples, right? If I will be having more samples, I will simply say I will get the better prediction, right? Yes or no? Because if you're having more sample, right, you can see, okay, in mathematics, you know what is the value of n by n, sorry, 1 by n if n is tending to infinity? it will tend to
0, 0.
0, right? So if you see if n is large, right? If n is very large, then this will tend to 0 or not?
Yes, 0.
Correct?
Yes, sir.
If this will tend to 0, that means variance is less, or there is very less variance in your data.
Yes, sir.
Correct? If variance is less, then your prediction will be better. Yes or no? Correct? So that is the something. So here n is your sample size. Whenever you are having more samples, you will get the better result. For example, let me do a quick example further. Suppose I'm saying x1, x2 up to x10. Okay. I'm saying this is from IID binomial, same, let's say 9 comma 1 by 3. Okay, I mean this is the x. So what is the, okay, tell me, everyone has pen and paper right now? Yes or no?
Yes,
Yes, sir.
Okay.
Yes,
So I'm
sir.
giving to you 2 minutes. Just tell me what will be the expectation of x bar and what will be the variance of x bar.
Nine and 1 by 30.
No, expectation is 3.
3. Yes, sir. 3.
And variance is 2.
2 by 9, no?
Sir, variance is 0.2.
Variance will be 0.2. So
Sir,
Variance,
30 and 20.
variance is
0.2.
Variance
0.2.
is variance is 2 actually.
2 by
The
9, sir.
variance
2
will
by 9.
be 2 by 9.
Yes, 2 by 9, sir.
I'm getting
Sir,
different set
variance
of
will
answers.
be
Okay, first of all, tell me.
No,
Okay. Don't worry. See, as per the definition, as of now, what will the expectation of x bar? It should be the mu, right? So this mu
Mu
is
value.
nothing but mu of this, right?
Yes.
And variance of x bar should be sigma square by n, and
Over
this
n.
sigma square is nothing but variance of this distribution. Is this
Yes.
clear? What I'm talking about as of now? Fine. Now let's calculate the mu. So mu is
Mu
nothing but
9.
n into p. So 9 into 1 by 3.
1 by
3, 3.
Yes or no? See, what is the
Yes, yes.
basic mean of binomial? N into p, right?
Right, and P.
So I'm this okay. We focus. This n. I'm not talking about this n 10. I'm talking about this mean of the binomial distribution. Okay. Be clear. So it will be 9 into 1 by 3, which is nothing but 3. Correct?
Yes.
Yes or no? If mu is this 3, then can I simply say expectation of x bar is 3?
Yes, sir.
And variance of x bar will be what? Sigma square by n. So this n, this is the sample size, means this 10. Okay.
1 by 30.
Variance is
So see, what is the
0
variance?
0.2.
Variance is n into p into 1 minus p. That is 1 minus 1 by 3 divided by 10. Okay. Are you able to differentiate what I'm talking about?
0.4, sir.
So it's a 3 into 2 by 3 divided by 10. So 3 will get cancelled out. It's a 0.2.
0.2.
Variance of x bar is 0.2. Is this clear?
Yes, sir.
You can do in reverse order also. Reverse order means by the whole algorithm. Means expectation of x bar is nothing but x1 plus x2 up to x10 divided by 10. This is something you can compute.
why you are dividing by 10? It is 9, right?
No. So okay, that is something I told you, right? Is n, this n is not about this binomial. This n is sample size. If you see in the previous example, what this n we are getting x1, x2, xn. So these are the size of your sample which is taken from x, right? Are you?
And what is that n indicate?
Each that x1 is following sir binomial 9. That is
Each x is following binomial 9, 1 by
1 by
3. Okay. Okay. This is, don't get confused with this n. Okay. For example, suppose I'm saying it's a Poisson distribution, let's say with parameter lambda 3. Then tell me what will be the mean expectation of x bar?
3 से 3.
1 by 3.
3, right? No, lambda is 3. And what will be the variance of x bar then?
3.
1 by lambda square, sir.
3.
You are telling me the variance of exponential distribution. Don't get confused in Poisson exponential. I'm asking what will the variance of x bar then?
0.3.
3 by 10, right?
Yes, sir, 3 by 10.
Okay, let me write separately. First of all, let me do this one. Okay, so each x is from binomial distribution, right? So I can write 1 by 10 expectation of x1 plus up to expectation of x10, right? If each xi from binomial 9, 1 by 3, then what will be the expectation of x1? 9 into 1 by 3 plus 9 into 1 by 3 up to 10 times 9 into 1 by 3, right? Yes or no? It will be 10 times 9 into 1 by 3 divided by 10. 10 will get cancelled. 3 times, 3 3 are 9. So we'll get expectation of x bar is as 3, which is same as here. Is this clear? Are you able to differentiate which I'm talking which n is this? This is the sample size. Yes or no?
Yes.
Is this fine for all?
Yes, sir.
Okay, what
First,
about
we
variance?
calculate the expectation and variance of the binomial
Correct.
by using its formula.
Correct, because that
and
mu,
divide
that mu
divide it by
sigma,
the number
sigma
of
square is
IIDs.
yes. That mu and sigma square is from it's okay. What is the variance of x bar? So variance of x bar means I'm talking x bar is x1 plus x2 plus up to x10 divided by 10, right? So I can simply write 1 upon 10 square. Yes or no? Then variance of x1 plus variance of x2 plus up to variance of x10, right? Yes or no? So it will be 1 upon 10 square. And what is the variance of each exercise? It will be 9 into 3 into
1 by 3 into 2 by 3.
sorry, 1 by 3 into 2 by 3, right? I'm just multiplying by 10 because it will be 10 times, right? We are going to add 10 times. Yes or no? Is this fine? So 10 will get cancelled out. It will be 3 will get cancelled out. With the 9, we got 2 by 10, which is nothing but 2.2. So this is something you can do manually also, or else if you know the property, you can simply do. Okay, don't get confusion with n. So this n is for sample size. Okay, now is this clear? Is this fine?
Yes, sir, clear.
Fine.
And so 9 is what? 10 is the sample size and 9?
This 9 is nothing but I'm talking about binomial distribution.
Okay, probably.
Okay. Correct. So this
binomial.
follows the distribution binomial. Okay, let's just consider this as instead of x1. Okay, this means x1 is from binomial 9, 1 by 3, right? This means x1 can take value 0, 1 to up to 9 with probability 1 by 3. Similarly, x2 is follows binomial 9, 1 by 3. Similarly, x3. But here I'm taking 10 samples similarly. Now, is this clear? The variance, actually the variance of x bar is sigma square by n. So this n is for sample size. Is the difference okay? Is the difference clear now? Yes, no?
Yes, sir.
Correct. For example, let's do another example. Suppose I'm saying x1, x2 up to let's say x10. These are IID samples. Let's say from which distribution? Let's say exponential for exponential. Let's say with lambda is let's say 5, for example. Then what is the expectation of x bar first of all? And so it will be mu as per the property, and variance of x bar should be sigma square by n. So this mu is nothing but mean of this case. Okay, and sigma square is nothing but variance of from the exponential distribution, right? And this n is nothing but the sample size, and this sample size is what now? It's a 10. Yes or no?
Yes.
Correct. Now tell me, what is the mean of exponential distribution?
5.
1 by 5,
by
sir.
1 by lambda, right? So I can simply say expectation of x bar is 1 by 5. Yes or no? And variance of x bar will be sigma square by n. So what is the variance in case of exponential distribution? It's a 1 by lambda square. So lambda is 5. It will be 1 by 5 square into n. N is what?
10.
10. So we'll get 1 by 250. Yes or no? Is this
Yes.
fine? So you can simply see, if, okay, for example, just assume here, if you have sample size n as 100, then you will get 1 by 2500.
Yes.
Yes, sir.
If n is, let's say, 1000, then you will get 1 by 25,000. So you can see variance is what is the decreasing. If n is increasing, then variance is decreasing here.
Yes, sir.
Are you getting what I'm trying to say here?
Yes, sir.
Okay, so that means whenever n will increase, right, n will tend to infinity, your variance of x bar will tend to 0, because variance of x bar is nothing but sigma square by n, then it will tend to 0. That's why we are preferring to have the more samples. Okay, is this fine, right? Okay, so far so good. Yes, no.
Yes, sir.
Yeah, fine. Okay, if you'll acknowledge that, then I will get whether you are getting the idea or not. Otherwise, I will simply assume you are getting the things. Okay. So let's move to the next topic called the sample variance. Okay. So sample variance is nothing but, let's suppose I have the same thing. If x1, x2, xn, these are IID samples. Okay. And from any distribution. Okay. And I'm defining from a distribution x, and I'm defining x bar as x1 plus x2 plus xn divided by n. So then the sample variance is nothing but, is defined as s square, nothing but x1 minus x bar square plus x2 minus x bar square plus up to xn minus x bar whole square divided by n minus 1. So this is something we have seen in stats 1 course also. This is something sample variance is defined as. Actually, one more thing, can you tell me for different, okay, just give me a minute, let me connect to laptop charging. Okay, so for different sampling instances, can you tell me, I will get the different values of sample square?
Yes, sir.
Yes or no? Because each exercise will take different values, correct? Then in a similar way, I will get the different values of s square or not?
Sir, each xi may take different value or surely will take different value?
No, it depends on how you are taking the samples. It can take different values, right? For example, I took the binomial example, right? Sorry, Bernoulli. In the case of Bernoulli, if you see, suppose x1, x2, x5 are Bernoulli, so it can take 0, 0, 1, 1, 0. That's one possibility, right?
These are independent.
Yeah, it's IID. It's IID.
There are chances that they may collide. No?
They may collide, but not always, right?
Okay.
Correct? But in
Sir,
general, I will say it will take different values, right?
Okay.
Sir, in this binomial expression, so first which you solved, sigma square is 2. Yeah.
Yes.
Yeah. If we how
Sigma
it
square is
is
2.
how it is coming? Yeah, from formula I got it np1 minus p. But
That is
from the
some
binomial,
that is the binomial variance of the binomial distribution, right?
yeah, np1 minus p.
Correct. So this is the variance. Okay. Fine.
Yeah, but sigma. Okay. Okay. Okay.
The sigma square is variance of that your
What is the
sample.
difference between that variance and this variance?
In which difference?
There,
Okay,
that
that is
sigma.
okay. That sigma square is nothing but it's called a population variance. Population variance is, let me define. It's called distribution variance. Means you have the information about your distribution variance, right? Suppose I'm saying x1, x2, xn are IID from binomial. Then you will be binomial. Let's say 5 comma half. Then you have the information about variance of binomial distribution, right? The population thing, correct? Population thing is from where the sample has been taken. So this sample variance is nothing but variance of the sample value, sampling instances. For example, suppose I'm saying x1, x2 up to xn, let's say x10, these are have been taken from the binomial, let's say same example 9 comma 1 by 3. Correct. So this means x1 is from binomial 9 comma 1 by 3. x2 has been taken from binomial 9 comma 1 by 2. Sigma square is nothing but 9 into 1 by 3 into 2 by 3. Okay. This is the distribution variance. Okay. And what is the sample variance? For example, for one sampling instance, your value is something like that 3, 2, 2, 0, 1, 0, 0, 1, 3, 3, 6, 1, 1, 4, 4, 8, let's say 2, 2. So this is the one sampling instance. Yes or no? So for this, your S square will be different. Correct? Similarly, suppose you got the samples like this 1, 0, 0, 0, 2, 3, 3, 1. Then again you will get some different sample variance, means variance of this sample value. Are you getting? So this sigma square is called distribution variance. Similarly, your mu is called distribution mean, means the samples from which samples from which distribution is has been taken. Is this clear now? Yes, no?
That sigma square can be called as population variance or the
distribution variance. Yeah. Okay. This is just a difference, different terminology for this. Okay. Fine.
Yes, yes.
Okay. Yeah. So as you can see, for different sampling instance, you will get the different sample variances. Yes or no? So can I say my S square is again a random variable?
Yes, sir.
Yes, sir. Okay. The same thing, if it's a random variable, I can find expectation of the sample variance also. And one important thing, the expected value of sample variance, okay, is nothing but S expectation of S square nothing but sigma square. Okay. So I'm not going to do the derivation as of now because already it's about 7. So we'll do the derivation I can do once your question will be over, or if you will get the time in mock, we'll do the derivation behind this, how we are getting expectation of S square as sigma square. But as you can see, expectation of S square is nothing but sigma. So it's called actually unbiased estimator. If you are getting confusion, what is the unbiased estimator and all, don't get confusion. We'll discuss in the week 9. Week 9, we are discussing biasness, unbiasedness, something like that. So you can see expectation of S square is sigma square. Also, we can find the variance of S square, but that is not in our course as of now. Okay. But in a similar way, if you see, okay, what about mean? Expectation of X bar was the mu, right? Variance of X bar was the sigma square by n, right? Similarly, if you see in S square, already n minus 1 is there in the numerator, sorry, in the denominator, correct? If you will calculate variance of S square, for sure you will get something terms related to n in the denominator.
Sir, this variance of x square, that is the variance of sample, right? And what we are getting into the, I mean, how
no, don't get confused variance of this thing. This S square, anyway, it's a random variable. We are talking about in general.
Okay, but actually they are same, right? Variance of x square and variance of sample variance is same, right?
No. It's about variance of S square. It means I'm talking about variance of S square means I will say variance of how we are defining S square, summation of xi minus x bar whole square divided by n minus 1, right? These are again another random variable. So it will be 1 upon n minus 1 square variance of summation of I to n xi minus x bar. Okay, are you getting now? So this is something. So we are not going in this derivation part here because it's not in this course. Okay, so what I'm trying to say here, if you see again in the denominator, n value is there, right? Sample size. Yes or no? So whenever n will increase, variance will decrease, right?
Correct.
So that is something I'm trying to explain here. So you can keep in your mind. So expectation of x bar, I mean expectation of sample mean is equal to distribution mean, and expectation of sample variance is equal to distribution variance or population variance. That is something I'm trying to explain. Is this fine? This terminology? Yes or no?
Sir, your last statement, sir. I could not hear.
Okay. So here you can see, and we got two things: expectation of x bar as mu, right? And expectation of s square as sigma square, right?
Yes.
So
this is of the full x1, x2 of everything, huh?
Correct, correct. So this is, I will say, expectation of sample mean is equal to distribution mean. Okay, this is called the distribution mean, or you can say population mean.
Okay, sir.
Population is from which where your sample has been taken. This is the sample variance. Okay, and this is called the population variance or distribution variance. Okay, this is just a terminology. Okay. So,
this way that s square I'm getting a little confused.
Okay, so this is s square nothing but sample variance, the sample which you have taken or you are going to collect for your study or objective for your analysis, then you will calculate the s square, right? Sample variance.
Okay, sir, I think got it. Can you please write it in a table left side and right side? What is sample and what is population? Like first, so what we discussed x bar, that is for population or distribution, and what we are discussing for s, that is for the sample.
No, x bar is for sample mean itself.
Oh, sample mean.
This means ex is for basically for one instant, and that is for multiple instance you're taking a variance.
No, see. X bar, see, anyway, x bar is the random variable, right? See, we are generalizing here. Okay, see, okay, let me clarify here. If you see x bar, where it went? Yeah. Okay, for this example, if you see, for one sampling instance, we are getting different value of x bar. For another, we are getting different x bar. Yes or no?
Yes.
Okay, so that's why I can say x bar is a random variable.
Yes.
If it's a random variable, I can find the expectation of that random variable. Yes or no? So expectation of that x bar, that means sample mean, is nothing but mu. We have derived it. Fine. So
Yes.
for this sampling instance, you will get some s square.
S square.
I can get, right, summation of x1 minus x bar square plus x2 minus x bar square divided by n minus 1, right? For this, again, I will get some different value of s square.
Yes.
So that means what? I can say this s square is nothing but random variable, because for different sampling instances, I will get different value of sample square variance. Fine. If this is a random variable, I can find the expectation of that random variable. Yes or no?
Yes, sir.
Correct. Similarly, we find expectation of x bar. We got mu. Similarly, I can find expectation of s square or not. That is something my question. Correct. So if you calculate the expectation of s square, I will get variance expectation of s square as a sigma square. The similar way which we calculated expectation of x bar, we got mu, right? If you derive this, we are not just doing the derivation. You can keep in mind as of now. So expectation of s square nothing but sigma square. So this sigma square just called the distribution mean or population mean. Is this fine now as of? Correct? Are you able to differentiate?
Sir, we can calculate the variance of also s square means sample variance.
Yes, that is something I told you, right? See, for this value, for this value,
variance of s square.
Yes, we can, but we are not doing in this as of now. Okay.
Okay.
So for our calculation, we are following the X bar approach, right? We are
Yes.
getting. Okay.
Yes, correct. So, okay. Tell me, for this example, for this sample, you can calculate the X bar. Suppose
Right.
you are getting 1 point something. Okay.
Yes.
Then for this, similarly, by using 2 minus, let's say X bar is 1.2. I'm just assuming. So you will do 2 minus 1.2 square plus 3 minus 1.2 square, something like that, up to divide by 9, means 10 minus 1. You will get some value of S square. Correct? Actually, so variance similarly, this is S2 is for variance of this sample. Okay. Fine. Is it clear now? Are you able to differentiate this terminology? Then we can move to the next thing. Okay. Fine. Yes. No. Anything?
Yes, sir. Yes, sir. Fine.
Okay. So another is scaling and summing property. I mean, what is the meaning of scaling? I mean, just we have to apply the properties of expectation and variances. So again, suppose I'm saying x1, let's say x1, x2 up to xn. These are the, I'm saying just independent. For example, just I'm taking independent as of now. Then I'm just defining s as a, let's say a1, x1 up to an, xn. Okay. And where ai are constant, it can belongs to any real number. Then what about expectation of S? Tell me, it will be expectation of A1 x1 plus up to AN xn or not? Correct?
Yes, sir.
Correct. So similarly, then I can write expectation of A1 x1 plus expectation of A2 x2 plus up to expectation of AN xn. Yes, no?
Yes, sir. Yes,
So
sir. Yes.
I can write now expectation of A1 times expectation of x1 plus A2 times expectation of x2 plus up to AN times expectation of xn, right? Okay. So
Yes,
this,
sir.
okay, this S don't assume it's a standard deviation. It's just one some notation of a different random variable. Okay. Similarly, what about variance of S here? So variance of it will be A1 x1. Now you will tell me what should I write the next. Tell me.
A1,
Variance.
A1
A1
Square.
plus
First of
A2.
all xi's are
A1
independent.
square.
All
Ah,
xi's are
okay.
independent, then I can separate the terms, right?
Yes, sir.
Correct? So this property you can keep in mind. It will help you actually. So this will be A1 square
A1
variance of
square be A1
x1
plus
plus A2
A2
square
square be
variance of x2 up to an square variance of xn. So this is when your xi's are independent only. Okay. What if all xi's are IID? If x1, x2 up to xn.
Variance is same for all.
So IID means what? It is from same probability distribution, right? If it's from same distribution, that means expectation and variances will be again same, right? So what is the expectation of S now? Then if you see here, all expectations will be same. This expectation of x1, x2, or 2 will be same as expectation of x, right?
N AN into X.
No, not an an. All are the, suppose all are different constant, then it will be a1 plus a2 plus up to an. Yes,
Whole into mu.
correct. This is something we can do. And what about variance of s? So variance of s, all the variances will be same, right?
Sigma
So I
square
can do,
upon n.
no, why sigma square by n? I'm not talking about variance of x bar, and this is just a variance of summation of your xi's. Okay, fine. Is this clear, right? Yes.
Yes, sir. Yes, sir. Clear.
Yeah. Now let's move to the one important topic called weak law of large number. Okay. So actually, this is something you can get from the Chebyshev also. Okay. So weak law of large number, what it does, actually it gives me the bound probability. I mean, it bounds the probabilities. Okay. Now, Let me just create the scenario. Suppose I am saying x1, x2 up to xn. These all are IID with x. Okay. And from any x, and this x has some mu. I don't know. It can, this x can be binomial, this x can be Poisson, this can be exponential, anything. And this x has the mean mu and variance as a sigma square. So this mu, I'm talking about population mu, means all this distribute x1, x2, xn, you can see we have taken from this x, and this x has the mean mu and variance sigma square. Okay. Now is this clear? This sigma square called population mean or distribution mean, because I'm collecting the samples from this x. Fine? Yes or no? And what is the x bar? We are defining x1 plus x2 up to xn divided by n, right? Then what is the values of x bar?
Mu.
Mu.
And variance of x bar?
Sigma square by n.
Sigma square by n. Okay, any one of you can tell me. See, we know expectation x bar is there, sigma is, sorry, mu is there, something like that. Is there anyone? Can you tell me in Chebyshev inequality? Sorry, in weak law of large number, there might be a question to you, like we know x bar, we know sorry, sample mean, population variance, and all, but there might be a question how far it is. Yes or no? Means basically what weak law of large number shows you. Basically, it basically show me, or it will give you the answer. How will you? Okay, we write that thing. That weak law of large number is gives you the answer of the question. How will you quantify? I mean, how close your x bar and mu are? Okay, that is something we are checking with the weak law of large number. Okay, so basically, for example, suppose for your sample, okay, so what I mean here is, suppose mu is here, for example, okay, your distribution mu is here, and some distance from mu minus delta and mu plus delta, some sort of distance, something like that. Okay, so you might be interested whether your x bar is more than this or your x bar is less than this. Yes or no? You can say, right, my x bar is greater than some this mu plus delta, or you can say x bar is less than mu minus delta. Yes or no? Can I say? I'm interested in this, right? I may be interested, right? So this means what?
Yes.
I can simply say x bar minus mu is greater than delta or not. Basically, if you see, this means what? X bar minus mu greater than delta, and this means x bar minus mu is less than delta. So combining this, I can say my x bar, I mean the absolute difference between x bar and mu, that means sample mean and population mean, is there is a slightly different, it is more than some delta. Yes or no? Are you getting this point?
Yes.
Okay.
Yes, sir.
This is
Yes, sir.
something, I mean, the weak law of large number helps us to know these things. So weak law of large number, basically, it will tell you the probability that modulus of, I mean, absolute value of x bar minus mu greater than delta, it is less or equal to sigma square divided by n delta square. The same thing you can see with the Chebyshev inequality. Okay. In Chebyshev inequality, actually Chebyshev inequality is defined for a single random value. In Chebyshev inequality, what we are getting? Probability that absolute value of x minus mu greater than some k sigma or its epsilon less or equal to variance of x divided by epsilon square. Yes or no? This was in Chebyshev inequality, correct?
Sir, what is delta in the WLLM?
Okay, delta is just a difference from, okay, this is this distance that I'm talking about. This distance, this distance is delta. Okay, suppose the air is mu, so this is the mu plus delta, and this is the mu minus delta. Okay, so now are you getting? So here you can see instead of x, I have x bar, right? So can I say it is same as probability that modulus of x bar minus mu greater than, for example, suppose instead of epsilon I have delta, let's say epsilon. So it will be less or equal to variance of x bar. Yes or no? See, at the place of x, I will be having now x bar.
X bar, yes.
So probability that modulus of x bar minus mu greater than epsilon less than, what is the variance of x bar? We have done just a few seconds before.
Sigma square by n.
Sigma square by n epsilon square, right? So instead, you can see this epsilon. You can, if you replace with delta, we got the Sevier inequality. Sorry, weak law of large number. Yes or no?
Yes, sir.
Okay. So this weak law of large number, it helps you to know the how close your x bar and mu are. Okay. So basically, if you see my weak law of large number, I will be having. So just try to understand absolute difference between sample mean and population mean is just greater than some delta. This is less or equal to sigma square by n delta square. So this sigma square by n is nothing but variance of your x bar, right? So can I say here with this inequality, if n will 10, n will be large, then this will be 10 to 0 or not?
Yes, sir.
Are you getting my point? So this means what? Are you saying? Okay, so this you are saying probability that absolute difference between sample mean and distribution is greater than some delta. This probability is converges to 0 when n is large. That means what? So probability of a null event is normally 0, right? Probability of a null event is 0. Correct? Are you getting what I'm trying to say? This means what? Can I say here x bar is very close to mu? Yes or no? This means what? Can I interpret these things from here? Means probability of a null event is 0. And here your event is, you are saying x, there is a difference. I mean, absolute difference between x bar and mu is greater than some value. Now, and probability for that event is 0. That means it's a very less, I mean, absolute difference is very less, right? Yes or no? So you can say your x bar is very close to you, mu. Fine. Are you getting?
Okay. That
fine.
Okay.
Right? Is this fine for everyone? Or else, if you can do in reverse order also, then probability that modulus of x bar minus mu less than delta, can I write greater or equal to 1 minus sigma square by n delta square? Yes or no?
Yes, sir.
If this
Yes,
is the
sir.
case, if n will be large, you will say it will tend to 0. Sorry, it will tend to 1 because this will tend to 0. This quantity will tend to 0 and is large, then you will say probability that x bar minus mu less than delta greater or equal to 1. Basically, it will tend to 1. Are you getting what I'm trying to say here? Is this clear? This step? Is this clear? Yes, no?
Yes, sir.
Okay. So this means what? What you can interpret from here, anyone? What the things you can interpret from here? Anyone? The same thing, that's something which you have interpreted in the previous. What the thing you can interpret from here?
Sample mean and population mean will be same, sir.
Yeah, it's very close to each other, basically. This means what? Okay, what is the probability of
Yes,
sure?
sir.
We are saying probability of a sure event is 1, right? You know, probability
Highly
of
probable. This event is highly probable then.
correct. That means, so what is my event here? I'm saying absolute difference between sample mean and population mean is very less. Correct? My event is absolute difference between sample mean and population mean is very less, and probability for that event is converged to 1. That means it's a very sure event. Yes or no?
Sir,
yes.
Yes, sir.
that difference is delta. But how
Delta is the less quantity actually.
Okay.
From here, can we conclude that delta is tending to 0?
No, not delta is tending to 0. This whole quantity will tend to 0 because n is there, right?
Because of n.
Okay.
But here, sir, how can we say that delta is?
So in left hand side, can we say that delta is tending to 0?
Yeah, delta is very small quantity. Delta is close to 0 actually. Now we are taking, we can't say, see. Okay, let's listen me carefully.
Sample mean are same.
Sorry. See, this
Does
delta
it
is,
say that?
see, this delta is
Same.
very small quantity, small, so that I can interpret x bar is close to mu. Okay.
Mu, right.
Okay. That is something what I'm trying to explain
sir.
here. So this is something I'm
If
saying.
delta is
small, actually
delta
small.
Is,
it's enough
if
small.
Delta, if delta is very small, sir, and then probability is 1 in that very small space.
Correct, correct. So that means something what I'm trying to say, x bar is close to mu. That's all. Right?
Okay.
Right? Okay. So weak log large number is fine to everyone. Okay. So tell me, what is this? This is upper bound or lower bound?
Upper bound.
This is the upper bound. Okay. Because this probability cannot exceed that quantity, right? And what is about what about this whole thing? It's a
lower bound.
Lower bound. Okay. Now I'm going to write a question, example for the same thing. Let me know if you need. Suppose I'm saying x1, x2 up to x50 are IID. These all are from Bernoulli. Let's say 3 by 5. Okay. Then I'm saying find the lower bound. Okay. On the probability that okay, this will I will solve, and after that I will give you one, and so that you can get an idea how to solve. Sample mean lies in the interval 0.5 and 0.7. So what is the question? Question is asking probability that sample mean will lie from 0.5 and 0.7, right? This is the question. Yes or no? So by the weak law of large number or Chebyshev inequality, okay, so it's asking about lower bound. Okay, so what is the thing? This is the case, right? This probability that modulus of x bar minus mu less than delta greater or equal to 1 minus sigma square divided by n delta square, right? This is the lower bound, correct? So if you see, can I write here minus delta less than x minus mu less than delta, left hand side, or not? Yes or no? If I separate this modulus term, I will get this thing. Similarly, I can get mu minus delta less than x bar less than mu plus delta greater or equal to 1 minus sigma square divided by n delta square, or not? Fine?
Yes.
So what is the thing you have to calculate here? This should be greater or equal to, so this is what? Mu minus delta. This is what? Mu plus delta. This will be greater or equal to 1 minus sigma square divided by n delta square. So what are the things you have to find? Oh, okay, first of all, tell me.
Delta.
What is the n here?
To find delta, and
n is?
N is 0.5.
N is 50, right?
50.
And what about sigma square? Sigma square, this is nothing but from here you will calculate distribution mean. Sigma square will be
6 by 25.
1 minus p.
6 by 25.
Into 1 minus
6 by 25.
6 by 25, right? Now, so what is the value of mu? Mu also required 3 by 5.
Yes, sir.
Correct? Why mu needed? Because you have to find the value of delta square. So you can see mu plus delta is what? 0.7. So mu is what here? Mu is 3 by 5 plus delta is nothing but 0.7. So delta will be 0.7 minus 3 by 5. Okay. So delta is nothing but 0.7 minus 0.6, which is nothing but 0.1. Correct? Yes or no?
Yes.
Are you getting?
Yes.
So delta is 0.1 and sigma square is nothing but, so here it will be, I'm just writing the values. So it will be, I mean this quantity will be equal to 1 minus sigma square is 6 by 25 divided by n is 50 into 0.1 square. So the value which you will get after calculating the right hand side, this will be the lower bound. Is this fine? Yes, no? Correct? Is this all right, right?
Yes, sir.
Yes, sir. Yes, sir.
Yes,
So I'm
sir.
just giving one question similar to this. Okay. Suppose this is IID exponential 1 by 10. Okay. So I'm asking, find the probability that your sample will lie between 6 and 14. Okay. So I'm going to give you some 2 minutes. After 2 minutes, we'll solve this question. Okay. Just solve it, and I know the I need answer.
So in previous question, how 6 by 25? Uh,
P into 1 minus P.
but that is mu, no? Okay, okay.
No, that is variance. Expected value is P.
Got it.
Sir, in this, are you asking the lower bound?
Yeah, because in this case we will get the lower bound, right? We can't get upper bound in this case, right?
Okay, okay, okay.
Because if you see, if you expand this term for the lower bound, only then I can get this thing, right?
Mm-hmm.
This is something we have to just keep in our mind. Okay, did you get what is the lower bound, value of the lower bound?
Yeah, yeah, just.
So in previous question, what was n? N was the one in the Bernoulli. 3
And
by
what?
5 was P. What was the n in the previous question?
No, you will tell me what is the value of n. What first of all n denotes here?
No, not in this question. In last question.
In the last question itself, what n?
50. Yeah, sample.
Here n will
Usually,
denote the sample size. Okay.
yeah, that is 50. That is 50. But for the Bernoulli 3 by 5, I was not able to see the question.
Okay.
Yeah, yeah.
What is the mean or expectation of Bernoulli distribution?
Yeah, it is mu or
And what is the
P.
okay? What is
NP1
the
minus P.
fine? It's clear now.
Yeah, so NP. So this is 3 by 5 is mu.
In case of Bernoulli, what is the expectation of Bernoulli? What is mean of Bernoulli
Yeah, yeah.
distribution? It's a P, right? And variance
Yeah,
is
yeah,
P
P.
into 1 minus Q. The same thing I have done. Correct?
Oh, got it.
Got it? Yeah. Tell me, what is the expectation of, okay, this is something I have to calculate. It will be greater or equal to 1 minus sigma square divided by n delta square, right?
Mu is 10.
Correct? Okay, this is something we have to calculate. Yes or no? So this sigma square, we have to identify. This delta square, I have to identify. And also, I mean, everything we have to calculate here. So can you tell me, so if you see the same form, I have to use this form, right? Correct. So what is this? Probability that mu minus delta less than x bar less than mu plus delta should be greater or equal to 1 minus sigma square divided by n delta square. Only then I will get the lower bound. Okay. So here I can say mu minus delta is 6, right? Yes or no?
Delta is
okay. So what is the
delta
mu
is
first of
4.
all? So mu is nothing but 1 by lambda. So it will be 10. And sigma
10.
square is
Delta
1
is
by
4.
lambda square. That means
1 by 100. 1 by 100.
No, not 1 by
100.
100 only, right?
Sorry.
Yeah.
100.
Okay.
Yes, yes.
So what is
And
the
delta
mu?
is 6.
Correct. So what is the mu? Mu is
100.
10 minus
10.
is
10
delta
minus
equal to
delta is equal to 4.
so delta is 4.
Delta is 4.
Correct. Now, can I calculate directly now? So it will be
Can you please
for
explain this step?
this step. So this is same as
Yes.
it will be mu minus delta, and this will be mu plus delta, right?
So where do you get the mu minus delta greater than x bar less than mu
Okay,
plus
did you
delta?
join the session now?
Yes.
I mean, you just joined session just now, right?
No, sir.
Okay,
From the
so
starting.
then you are not focusing here. Okay, so this is the one for another form of the weak law of large number, right? So if you expand this form, that means I will get minus delta less than x bar minus mu less than delta. Correct? Then I can write
Yes,
mu
sir.
minus delta less than x bar less than mu plus delta. Correct?
Yes, sir.
So if you see, question is 6 less than x bar less than 14. So which form is this? This form? Correct?
Yes, sir.
So I can say mu minus delta is 6 and mu plus delta is 4. Sorry, 40. So if you use any
Yes.
mu minus delta or mu plus delta, you will get delta as 4. Okay. So here, if you see what we got, probability that 6 less than x bar less than 14 greater or equal to 1 minus sigma square we have calculated as 100 and is how much? 50, right? And sigma square is 4 square. Sorry, delta square 4 square. Whatever value you will get, it will give you the lower bound in this case. Is this fine? Clear or not?
Yes. 7 by 8 we get.
Yeah, whatever the things we will get. Okay, is this fine? Okay, let's do for upper bound one question, then we'll move to the next topic because anyway we have to. Okay, suppose I'm saying x1, x2 up to let's say x50. For example, I'm saying this is IID Bernoulli, let's say 2 by 5. Now be focused what I'm going to write here. Find an upper bound. Okay. You can keep in your mind any of the anyway the in the formula sheet, right? The form of weak law of large number will be provided to you. Okay, which is just another form of Chebyshev inequality. You can say in just keep in your mind. Okay, upper bound on the probability that the sample mean will be at least, let's say 0.2 units away from the actual mean, or you can say distribution mean. Now, can you tell me what I'm talking about here? Just focus. We have to find the upper bound of the probability that sample mean will be at least 0.2 units away from the actual mean. That means what? Probability of what?
R minus mu is given.
Delta greater than.
X bar minus, which is sample mean,
Minus mu
is
0.2.
minus mu is greater than 0.2. Yes or no?
Yes, sir.
Right? This is something meaning. So if you see, we have the weak law of large number. We know there is a one form called x bar minus mu greater than delta. This is less or equal to sigma square divided by n delta square, or not? Correct? This is the upper bound, right? Yes or no?
Sir, it's saying at least 0.2. So it should be greater than or equal to
anything, no problem. Okay.
0.2.
Okay. So this is basically it should be more than 0.2. Okay. So it should be greater, sorry, less or equal to sigma square divided by n delta square. Okay. So what is your n here?
50.
50. And what is the sigma square? Means P into 1 minus P. So P by 5 into 3 by 5. Again
6 by 25.
6 upon 25, sir.
There is some background noise, so please mute if you don't have it. Okay. So it will be 6 by 25, right? Divide by n is 50 and delta is 0.2 square. Okay. Now you'll be able to know when to use which case, when to use case, right? I'm just assuming. Okay. Fine.
Yes, sir.
You can keep in your mind just one formula. If suppose this formula is given, that means another will be probability that modulus of x bar minus mu less than delta, it will be greater or equal to 1 minus sigma square divided by n delta square. That's all. This is
for lower bound.
It's a lower bound. Is this fine? Okay.
Sir, if same question will ask you in lower bound, how will the question will frame?
So question will be framed, your x bar is in between some value. Because if you solve this, right? If you solve this lower bound, so I will get minus delta less than x bar minus mu less than delta. Then I will say probability that mu minus delta less than x bar less than mu plus delta, right? Then you will say your x bar is in between. As you can see in the previous question, your x bar is in 6 and 14. Then you have used the lower bound. Okay. Right?
When it will be in between, it will be lower bound.
Lower bound, yeah. You can see, don't memorize the things. You can simply use this formula or this formula. If you just expand, you will get the idea. Okay. Don't just memorize the randomly. Okay. Fine. Okay. Is this clear as of now? So far, so good.
The last problem, we know the sigma square, which is 6 by 25. We know the n, and delta is also given.
Correct.
Okay.
Fine.
Just show me the second last problem, sir. I guess
this one. Okay, this one. This one.
Okay. This is that lower bound one here.
Correct. Okay, so in case of this one, okay, in case of upper bound also, it can be given you at least 0.2 units away from the actual mean, or else it can be like this. Okay, just a frame of step. Suppose this is greater than delta, right? Okay, so can I say this x bar minus mu is greater than delta? Can I say x bar minus mu is greater than delta, or x bar minus mu less than minus delta? Yes or no?
Yes.
Then can I say x bar is greater than mu plus delta, or x bar is less than mu minus delta? Okay. If question is something, your probability that x bar is greater than some quantity or x bar is less than some quantity, you can simply use the upper bound case. Yes or no? If there is a case of x bar is, let's say, in between mu minus delta and mu plus delta, I will simply use the it's a less than equal to 1 minus sigma square by n delta. This is lower bound. Is this clear? The difference? Okay. Fine. The simple thing what you can do, just go with this. You can simply expand. You will get the idea, or else you can just do the reverse order. You will get that. Fine.
Okay, sir.
Anyway, don't worry. This form will be given in your formula set. Okay. Fine.
Yes,
so far,
sir.
so good. So far, so good. Any doubt?
No,
Sir,
sir.
why this is called as weak law?
Of large number.
Yeah. Why this is weak, sir? Weak.
Yeah, because we are talking about in terms of probability. It will give you a weak bound. It's not give you a strong thing.
It is not based on data points. It is calculated.
Actually, here we are talking about improbability. Probability of this is less than something. Actually, it gives me, see, this bound is no. You can see this bound, right? It's actually weak bound. Okay. So I mean, there is something we are not. I mean, that's not important or foundational point of view. You can see the something convergence in probability. You can search on Google, or if you have some statistics book, convergence in probability. So there is something probability in distribution. Means okay, here okay. If you are saying by the weak law of large number, I will say x bar is close to mu in probability. Means it will give you weak bound. While in distribution means you will say x bar is in distribution with mu, then that means you are almost sure. You are almost sure your x bar is very close to mu. Here x bar is close to mu. That's something you can say, but it's in probability. Okay, that is, see, these are, we are not, that's a little bit depth in statistics part, but I'm just giving you idea what's the difference in this. Okay, there is something you can search, strong law of large number. This will give you this thing actually. Fine.
Yes, sir.
Okay, yeah. So next topic is we are going to study called moment generating function. Okay. Okay. So the short form is MGF. So why we are calling it a moment generating function? Anyone?
Because it's generating the movements.
You are just telling the another in another. Why am I asking why it's called moment generating function?
It gives the moment of expectations.
No, expectation of x is again one moment actually. Okay, let me give you a rough idea. Okay, suppose I have a data set 12, 14, 14, let's say 17 and 18 for example. So I will in physics, if you can remember, suppose this is the zero starting point. For example, suppose 12 is there, then 14 will be there here. Okay. Suppose 17 is here and 18 is here. Okay. Something like that. I mean, these are the 2 points here, 14, 14. Okay. So in physics, we are interested distance from this point to this point, right? Okay. So here we are interested in average distance from zero. I'm just giving you rough idea. Then we'll not go in depth. So how we can calculate this? This is nothing but you can simply calculate summation of xi divided by n, average distance from zero, which is something we are in terms of statistics we are calling, it's called a first moment. Okay.
Can you repeat that again?
Okay. In physics, what we are doing? In physics, we are simply interested in distance from this point to this point, right? To all these points, correct?
Yes, sir.
So in statistics, if you see average distance from 0 to this point, these all points, right? Let's say till 12. So what is the average distance from 0? So this is average, how you can calculate the average distance, summation of xi divided by n, right? So this is something called the first moment. Okay, in statistics, we are treating as the nomenclature is first moment. Similarly, second moment is what? I will say summation of xi square divided by n. Okay, this is something average squared distance where from 0. So this is called second moment. Okay. In statistics, we are treating as a second moment. Okay. Are you getting some sort of idea? Okay. So for example, sometimes we are doing average distance from, okay, okay, is it always from 0 or it can be from another point also? It can be, right? Yes or no? What's the, okay, so can I say
Yes,
what's
sir.
the
It
mean of,
can be another point,
okay,
sir.
what is the mean of these data observations? Let's say mu1 dash. Okay, let's say mu1 dash is the mean. Okay, so
Sum of the observation upon number of
correct. So how
observations.
I can find the average distance from the mean? Tell me. How will you find average distance from the 0? It was summation xi from divided by n. What about average distance from mean? That means we are talking about distance of each value
Xi
from
minus
this
x
mean.
bar over mu over n.
Correct. This is something I'm talking. Correct. So this is again called the, I mean, first moment. If you are talking about average distance from mean. Similarly, average square distance from mean, it will give you xi minus, let's say mu dash square divided by n. This is called the second moment. Okay, some sort of idea is clear why we are treating moment and all. Then we'll move to the I mean the our original thing. Is this fine? Moment means we are talking about distance from 0 or distance from a point, distance from a mean. It can be anything. Okay. So in moment generating function, how we can calculate actually, if you talk about random variable in terms of random variable, suppose I'm saying let x is a random variable. Okay. Then how will you calculate the MGF of x? So MGF of x is basically nothing but mx. We are denoting it's the function from R to R, which is defined as, okay, mx lambda is nothing but expectation of e raised power lambda x. Okay. I will come to the point. What are the meaning of these things? Actually, expectation of lambda x. So if lambda is something, okay. So in what are the meaning of moments actually? Moments means expectation of x. I will say this is the first moment. Okay. Expectation of x square is nothing but second moment. Okay. Similarly, expectation of x cube will give you third moment. Okay. Up to expectation of, let's say, x raised power r, this will give you the rth moment. So where this moment and moment and all are useful, hopefully, have you heard about skewness and kurtosis and all?
Positive skewness and right
Correct,
negative
correct.
skewness.
Right skewness and all. So we, if you see, I mean that's something we are not going to discuss, but I'm just going to give you idea. If you see skewness and all, right? So skewness and kurtosis, have you heard about kurtosis? Skewness means whether it's a left skewed, right skewed, or it's a symmetric. I mean, basically skewness will give you the idea about symmetricity of your data set. Kurtosis will give you what is the form. Form is, let me tell you, kurtosis is nothing but, suppose your data is distributed like this. So this is something, and your data is something like this. Your data is something like this. Something, I mean, it's so something called leptokurtic. Okay. Then mesokurtic. I mean, basically, kurtosis is, tells us the peak of the distribution. Okay. Then platykurtic. Platykurtic and all. I mean, this is something we can calculate. If the coefficient are less, greater than 3, then mesokurtic equal to 3. Mesokurtic. Mesokurtic means normal distribution.
Peak is not always the mean is always the peak of this distribution, isn't it?
Yeah, it is normal distribution actually. See, that is something I'll just give you a rough idea. If you see the kurtosis, if you search on Google and all, kurtosis, you will get some skewness, kurtosis and all. So in this case, your skewness, this moments are useful. I mean, skewness and kurtosis you can calculate with the help of your moments actually. Okay. So this is something, I mean, your graph looks like this. Then you'll say leptokurtic means more than normal. Mesokurtic then penalty. I mean, this is not our interest of topic of the interest. I'm just telling you where movements will help you. So movements can help you to know the things about skewness and kurtosis of your data set. Okay. Now, if you see here, we have just mentioned expectation of x called
Which
first
moment
moment.
will help to know about skewness, and which moment will help about kurtosis?
Actually, as I can remember, it's mu1 dash squared divided by mu1 dash or mu2 square, something like that. I can't remember the whole, I mean, exact formula, but it will help you first and second moment. For kurtosis, some third and fourth is there, if I'm not wrong. Okay. I need to search this formula. So, but these moments and all is helpful in this field also. Is to know the skewness. Skewness will give you the idea about your symmetricity of data set, whether it's a left skewed, right skewed, or symmetrical. Yeah, please go ahead.
Sir, can we use differentiation for finding the first moment, second moment?
We can find. We can find
the
that.
first
Yeah,
moment.
something. Yeah, that is also we can use. But in this, we are just focusing in one approach actually. Okay. See, you can simply
One
go
more
there.
thing. In moment generating function, sir, what does delta represent?
Okay, moment. I mean, this is a kind of function which will give you the moments about your x. Okay, it will give you moment of let's say it will give you expectation of x. It will give you expectation of x square. It will give you expectation of x cube, something like that. Okay, all those with the help of those moments you can identify the symmetricity, kurtosis, and all something like that. That is the one of the use actually. If you will move to the week 9 onwards, then you will study method of moment. So in method of moment, what we are doing, we are using the moments to estimate our parameter of the distribution. Okay, when your parameter of distribution unknown. So these moments are very useful in another fields also. So this is the one of the example where you can use to know the what is the skewness or kurtosis and all. Okay. As of now, we are focusing how to calculate the moments. Okay. So if fine, is that all right? So mx lambda is denoted as expectation of e raised power lambda x. Okay, so this is something. So here x can be a discrete
Yes,
or
sir, expectation if you want to, oh sorry, sir.
yeah,
Sir,
go.
expectation if you want to understand, like it is a occurrence, probability of occurrence for how for lambda, like expectation of lambda, how we understand theoretically. And formula we
Yeah,
understand.
expectation is what? Tell me. It's a weighted average for each values, right?
Okay.
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 Here we are
Weighted
talking about.
value.
Yeah. So your if x is I'm talking if suppose x is discrete, okay, with some PMF, let's say probability p, let's say x equal to x, okay, and some range is tx, for example, then how will you calculate this case mx lambda? It will be expectation of e raised power lambda x. Then how will you calculate the? Then it will be summation of, in case of discrete, e raised power lambda x into probability x equal to x. Correct. In case of discrete distribution, how we are calculating expectation of x is nothing but summation of x into probability x equal to x, right? If this is the continuous, for example, if your x is continuous random variable with some PDF, okay, PDF f of x, then our mx lambda will be expectation of e raised power lambda. So it's the integration, because in continuous, what we are doing continuous summation. So it will be integration of e raised power lambda x into fx dx. Now is this fine? How we can calculate the expectation? Yes, no?
Yes, sir.
Fine. So tell me, okay, there is one more thing called, I will give you the example. Okay, first let's do the example. Suppose I'm saying x is taking values -1, 0, and 1. Okay, with equal probability 1/3, 1/3. Now tell me what is the mx lambda here? Okay, should I do first question? Yes, no? Okay, let me do. So this is the discrete, first of all, correct? So it will be expectation of e raised power lambda x. This is, so how will you define? This is summation of throughout the range of x e raised power lambda x into probability of x equal to x. Yes or no? Now, if you see, so it will be e raised power lambda. What is the first value of x? It's a -1 into what is the probability? 1/3 plus e raised power 0 into lambda into 1/3 plus e raised power 1 into lambda into 1/3. So what will get? 1/3 e raised power minus lambda plus 1/3, and e raised power 0, I mean something raised power 0 is 1, right? Plus 1/3 is for lambda. Yes or no?
Yes, sir.
Correct. This is something mx lambda for this case. Okay. Now I'm just giving another distribution. Tell me what will be the suppose this is taking -2, 1 with probability 1/4 and 3/4. This is the probability. Tell me what will the mx lambda is?
So what values do lambda take in the previous
Sorry?
question? What values do lambdas take in previous
No, it's
question?
not lambda defined here. It's just about expectation of is for lambda x. It's just values of x and probabilities is given to you. Lambda is not given to us here.
Okay.
Yeah. Yeah. So let me go to this. Just tell me what is the expectation of
1/4
1/4 into e to power -2 lambda
plus e
plus 3/4 e to power
3/4
minus
into e to power lambda.
Yeah, so it will be expectation of e raised power lambda x, right? So it will be summation throughout the range of x e raised power lambda x into probability x equal to x, right? So what we have, e raised power lambda of -2 into 1/4, right? Plus e raised power lambda into 1 into 3/4. This is something you got?
Yes, sir.
Yes. This is something. Yes. Now tell me one more thing. If this is the okay, forget about this. Suppose I'm simply saying to you, mx lambda is given to us. So let's say e raised power minus 2 lambda 1/3 plus e raised power, or let's say 1/3 plus e raised power e lambda. Okay, suppose I'm saying I have given a moment generating function of x like this. Can I find the distribution of x?
-2, 0, 2.
Correct. So the one application of this, if moment generating function is given to you, you can find the PMF or PDF of that distribution of your random variable, right? So from where I can say e raised power minus 2 lambda into 1/3 plus e raised power 0 into lambda into 1/3 and plus e raised power 2 lambda into 1/3, and we know mx lambda is what? Summation of x e raised power lambda x into probability x equal to x, right? So if you compare this, I will get value of x as -2, 0, 2. Okay.
With probability 1/3.
With probability 1/3. So one of the use is this in case of moment generating function means through the use of moment generating function, you can find the distribution of your random variable, or distribution is given to you, you can find the MGF also. Is this clear? Yes, no?
Yes, sir. One-to-one function, sir.
Yeah. Is it fine?
Yes.
Okay, so one more another thing also you can keep in your mind, actually, that is something you have to keep in your mind. I mean, if you've seen the lecture video, sir has also mentioned, if I'm saying x follows normal distribution with mean 0 and variance sigma square, then what is the moment generating function of this case? Anyone can tell me?
E to the power lambda square into sigma square by 2.
Right. So just this is something you can
So
say.
can we get this formula in the exam, or we
This
can
is something no, I think you can get if there is something question is there, but it's good if it's in your mind. Okay.
Okay.
Fine. So far it is fine to all of you. Any doubt? Yes. No. Right. All right. Okay. So okay. Tell me one more thing. Suppose I'm saying. Okay. For example, let me suppose I'm saying y is defined as x1 plus x2. Okay. It's the summation of your exercise, and I'm saying this x1 and x2 are independent. Okay. Now, so what is the MGF of y? What will the MGF of y? So the my lambda, I can simply say expectation of e raised power lambda y. Correct. This will be same as expectation of e raised power lambda. Instead of y, I have x1 plus x2. Correct. So if you simplify this, you will get e raised power lambda times of x1 plus lambda times of x2, and this is the inside this I can write expectation of e raised power lambda times of x1 into e raised power lambda times of x2. Yes or no?
Yes,
correct.
sir.
We know we have information x1 and x2 are independent, and we know if x1 and x2 are independent, then I can simply say expectation of x1 into x2. This will be same as product of their marginals, right? So can I say expectation of e raised power lambda x1 into e raised power lambda x2? Yes or no? So
Yes, sir. MGF1 and MGF2.
yeah, this will be mx1 of lambda into mx2 of lambda. So from here you can conclude summation of, moment generating function of sum of independent random variables is same as product of their individual MGF. Is that all right? Yes or no?
Yes, sir.
Correct. What if I'm saying x1 and x2 are IID? If this is the IID, MGF will be same. Correct. Then mx1 plus x2 lambda will be same as mx lambda whole square or not? Because
Yes, sir.
if this is the IID, all the things will be same, right? Is this clear?
Yes.
Yes, sir.
Yeah. So actually, let me do one more thing, then we'll move to the next part. Do you any session from 8?
Yes, sir. Maths 2 revision session.
Okay, okay. Let's try to do the before then. Okay, let me just give you idea. So E expectation of e raised for lambda x. You know what is the expansion of e raised for x? 1 plus x square by 2 factorial, x cube by 3 factorial, and so on, right? This is something expansion of e raised for x. Correct? So from here I can write expectation of
Yes, sir.
1 plus lambda x plus lambda square x square by 2 factorial plus lambda cube x cube divided by 3 factorial plus so on. Correct? So from here onwards, can I write 1 plus lambda expectation of x plus lambda square by 2 factorial into expectation of x square plus lambda cube divided by 3 factorial into expectation of x cube and so on. So if you observe carefully, this is the first moment and this is the second moment and this is the third moment, right? Something. So similarly, can I say expectation of x raised for I, if you observe carefully, what is this? This is nothing but, can I say coefficient of lambda raised for I divided by I factorial or not?
Yes, sir.
I can simply say, right? So this is something you can keep in your mind. Okay. Now let's move to the another topic called next topic, which is I think CLT, central limit theorem. Okay. What CLT tells us? Anyone? Anyone? Any thought?
We use CLT to approximate the probability.
Okay, correct. Very good. So what's the important property of CLT? This actually approximate the probability.
Yes.
Yeah.
X minus expectation of x upon a standard deviation is approx to the normal of 0, 1.
So any data can be presented in this form.
Correct. Any data, the very important property of central limit theorem is that irrespective of the initial distribution of your x size, okay, for large sample, whenever your sample size will be large, when n will tend to infinity, okay, then summation of your x size or mean of your x size will converge to the, it will be the normal distribution, irrespective of the x size. Okay, I mean you can cross check also. I mean maybe you have seen that if you see the calculators or tabulated value of t distribution. Okay, it's not in as of now. Okay, let's not go there, then you will get confusion. Let me just explain the central limit theorem actually. So what central limit theorem says, at x1 x2 xn, these are IID x, okay, from x, and this x, let's say with, I'm just assuming with expectation of x as 0 and variance of x as a sigma square. Okay, this is something. And I have defined another random variable, let's say y as, which is nothing but defined as x1 plus x2 plus so on plus xn divided by, let's say, square root of n. Okay, then actually this square root n is helpful for scaling. Okay, but I will tell you the main property of central limit. So my of lambda, basically what central, it will converge to, it will say my lambda is moment generating function of y, lambda will be moment generating function of y will be e raised to lambda square sigma square by 2. And you know what is this, right? So that means what? This means y is tend to converge to
Normal distribution.
normal 0 comma
1
sigma
Sigma
square.
Sigma
Because
square.
this is what ngf of 0 comma sigma square, right? Now this is agenda of CLT. I will tell you how to calculate the things. So I mean the key idea using CLT to approximate the probability. How to approximate the probability? Okay. So idea behind it. So let's do in general. General means suppose I'm saying x1, x2, so on xn these are IID with X. Okay. So and with expectation of X as a mu and variance of X as a sigma square. For example, this is the IID. So mean and variances will be the same. Okay. Now let me define a Y as a, let's say, summation of these Xi's. Okay. For example, then so what we have to do in CLT, what you have to keep in your mind to make the random variable in the, just convert the random variable standard normal variable. Okay. How you can calculate, how will you convert your random variable in standard normal form?
Y minus expectation upon
Yes.
standard deviation.
Basically, Y minus expectation of Y divided by
Y upon
standard
standard
deviation of
deviation.
Y, it will be normal 0, comma.
Normal 0 1.
This is something you can do. Okay,
0, 1,
if you once you will convert in standard normal form. Okay, so this I can simply denote as a G. So this means this G will be follow this this G will follow the normal distribution, basically standard normal distribution. Then whatever the calculation is there, let's say probability Z less or equal to something and all, then you can calculate with the, you can simply see the value of FZ and you can, okay, let me tell you, I will give you one example that will help you. Okay, so tell me what will the standard expectation of Y here? Y is defined as x1 plus x2, x2 plus xn. What will be the expectation of Y? Yeah, what will the expectation of Y?
Expectation of Y is mu, right? That same.
No, no,
N
not
into mu.
n
N
into mu,
into
right?
mu.
It's not by n.
Yeah, it will be n mu.
N mu, sir.
Diplo, are you getting
N mu.
expectation? Correct? Expectation of Y will be expectation of x1 up to expectation of xn, right? So it will be mu up to n
So
minus
N mu.
n mu, right? If you divide by n, you can simply you will get mu, right? So it will be n mu divided by what is the standard deviation of Y? So it will be, first of all, consider the variance.
Root
Sigma.
n
Root under n sigma
Sigma.
square.
First of all, variance will be n sigma square, right? So it will be n root sigma. It will follow normal 0, comma 1. Yes or no?
Yes, sir.
Correct. Now let me change the Y little bit different. Suppose I'm saying if Y is x1 plus x2 plus up to xn divided by n, that means x bar.
Simple mean.
Okay. Then tell me what will be the case? Y minus expectation of Y divided by standard deviation of Y will follow normal 0, comma 1, right?
Yes,
So
sir.
what is the Y minus what is expectation of Y?
Mu.
Mu.
What is the standard deviation of Y?
Root under sigma square upon n.
Correct. This is same as I can say x bar minus mu divided by sigma by root n. This is follow normal 0, comma 1 or not?
Yes.
Is
Yes,
this
sir.
fine?
Yes, sir.
Correct. So the key thing is for your central limit theorem is this. Okay. So let me give you some one example that.
Sir,
Mhm.
in previous what you have done when we are taking x equal x1 plus x2 without dividing n. Say sample deviation. Y have root n into mu.
Okay. What will be the variance of Y here?
Variance will be sir, n sigma square.
Then what will be the standard deviation then?
Root under. Got it, sir.
It is fine.
Yeah.
Okay. Yeah. So okay, just let me open the portal itself. I will take some example from that. Then we'll try to understand. Okay. Hope that will be fine, right? If we can take the questions from.
Yes, sir.
Just give me a second. Right. Just a minute. Okay, fine. So let me open the portal. Can you see my screen now? Is it visible?
Yes, sir. Visible.
Okay. So okay, can you see the question now? This one?
Yes, sir. Yes, sir. Which one?
Okay, let's see. Let's discuss about third. How many of you got the third question as correct? Okay, let's do this fourth one. Fourth one or third. Third, let's do first third, then we'll do fourth. So what question on third? An electric firm manufactures light bulbs that have a length of life that is approximately normally distributed. See, initially it's normally distributed given to with mean equal to 600 hours and standard deviation of 50 hours. So that means what? Mu is given to us 600 hours, right? And sigma is 50 hours, right? Yes or no?
Yes, sir.
So your question is a probability that find the probability that a random sample of 25 bulbs will have an average life of less than 615 hours. So what is the meaning of this uh, blue statement, which I have?
Sir, n is 25, x bar is 615.
X bar is 615. Can you read the question carefully? What is this? Random sample of anybody?
What, sir? Can you please explain again? What is it? No.
See, I'm asking the blue things, right, which I have highlighted with the blue color. What is the meaning of this line only?
So meaning of this that is probability of y greater than 615.
What is the y here? And why it's
Y,
greater?
sorry, less than. Sorry, less than.
What is your y here?
Y
Y
is
here is
average life of
it's
bulbs.
25
yes, a
bulbs,
life of
right?
bulb.
Yes.
Correct. So actually, in the case your x is length of life of bulb, right? And this is the expectation of x sigma is given to you, right? It is asking they have taken some 25 samples from the normal distribution. Actually, this is the normal, it's clearly mentioned. Then we have to approximate the probability that your average life is less than 615 hours. Is this the question, right? Correct. This is the some question.
Correct.
Yes,
To
this
use
is
the CLT, what we can do, we have to convert this as in the standard normal form. That means we have to do x bar minus expectation of x bar divided by standard deviation of x bar. Correct. So what is the expectation of x bar? We know it's a mu, which is same as 600.
600. Yes, sir.
And we have seen from Week-7 what is the variance of x bar? It's a sigma square by n.
Sigma square by
So what is
n.
the sigma square? Basically 50 square divided by what is the n? 25. Correct? Are you getting? So standard deviation will be how much? 50 divided by 5, that is 10. Is this clear? Yes? No?
Yes, sir.
Correct?
Yes, got it.
Is this clear, right? What from where we have to calculate, right? So you can see, so this will be probability. So this is nothing but now it will be G, right? I can simply convert in G because it's standard now. This is less than
Z
615 minus what is expectation of X bar now?
600
600 divided by 10. Correct?
root
So
10.
it will be probability G less than 15 divided by 10, which is nothing but probability G less than 1.5, which is same as Fg of 1.5. So this value will be given to you. Let me see
So
whether
I think sigma was given 50, no?
Sir,
Sir, sigma was given 50, no, in this problem.
yeah, one second. So you can see Fg 1.5 is 0.933. So answer is 0.933. Yeah, sigma was 25. Sorry, 50. Yeah, see
So
why
standard deviation will be root 10 now.
root 10? Why?
Where
No,
we
no.
have find
See.
variance.
You can do x minus expectation of x bar or standard deviation of x bar. This will follow normal distribution. Yes or no?
Yes, sir.
Correct. So what I have done, I have calculated the expectation of x bar and variance of x bar separately and got standard deviation as 10. If you see this, okay, let me do. What is the variance of, okay, variance of x bar is sigma square by n. This means standard deviation of x bar will be sigma by root 10, right? Yes or no?
Yes, sir. Yes,
Sigma
sir.
is what? 50 is given to us. Root 10 is
Yes,
what? 25. 50 divided by 5, which is 10.
Okay.
Right? I have calculated here 10. Now it's clear?
sir,
Yes?
could you please go to that question, sir?
Okay.
This X bar is 615, no?
X bar is?
615.
No, how? It is simply saying average life of bulbs, right? They have taken the random sample of 25 bulbs. They have, so what will be the average life? It will be X bar. So that X bar is less than 615. You have to calculate what is the probability. What will be the approximate probability for this case?
But sir, when you have substituted the value 615 in place of X bar, there I'm confused.
No, I have not I have not substitute like substituted this value 615.
Right side, sir.
Can you see this inequality?
Yes,
This
sir.
is something we have to calculate, right? Yes or no?
Sir,
in front of that, sir.
Probability of, okay, tell me, probability of X bar is less than 615. We have to calculate, yes or no?
Yes, sir.
So can I do X bar minus expectation of X bar?
Yes, sir.
Let me do separately again. See, X bar is less than 615, right? So if you will do X bar minus expectation of X bar, then both sides can I do 615 minus expectation of X bar? Yes or no? This is the inequality sign, correct?
Yes, sir. Just have a doubt here. Can we write x bar minus n mu divided by root n sigma?
No. Why n mu? X bar is x1 plus x2 plus xn divided by n, right? Okay, one second. You are getting confused. See, if you have x1, x2 up to xn, right? If your y is defined as x1 plus x2 plus so on xn, let's say these are from IID x and expectation of x is mu, variance of x is sigma square. If you see, if you are getting confused, right, just do the calculation part. Tell me what will be the expectation of y here? Expectation of x1 plus expectation of x2 plus so on expectation of xn, right? That means mu plus so on mu, that is n mu, right? Is this
Correct.
clear?
Correct.
What about variance of y? Variance of x1 plus up to variance of xn. This will be sigma square plus sigma square up to sigma square. This will be again n times of sigma square. Is this clear now? Right? Now the things x bar is there. X bar is nothing but it's a x1 plus x2 plus so on xn divided by n, right? So if we take, this is something I will define y, for example. Okay, let it be.
Sir, actually, I was telling the same thing. I'm saying that if we write this x bar minus n mu divided by root n sigma, so actually that is also standard form, right? You are getting that, no? Expectation of y is equal to n mu.
So what is the y here? Is the y x bar?
Oh, here
Y is just a summation.
Okay.
Let me clarify this one. If suppose this is the y now, so what you will do, expectation of x1 plus up to expectation of xn divide by n, right? So the y which you are getting confusion, this is n mu. So this is just numerator part here. If you are talking about x bar, right, then we have to divide by n. So it will be n mu divided by n. N will get cancelled out, which is again mu only. Is this fine? This is something we have discussed in the beginning of the session.
Okay. Yeah.
Now the difference is okay, right? If you do the if you calculate the variance of x bar, that means what? Variance of x1 plus x2 up to xn divided by n, right? In the previous one, what we have calculated variance of summation. So it will be 1 upon n square variance of x1 plus variance of x2 plus so on variance of xn, right? Yes or no?
Okay.
So it will be sigma square plus up to sigma square divided by n square. Now if you see the numerator part, this is only for summation of x's, right? Are you getting the difference now? So it will be n sigma square divided by n square, which is nothing but sigma square by n, which is variance of x bar. Is the difference clear now?
Yes, sir, got it.
Correct. So the thing is, what you to do, just keep in your mind whatever y is there, it can be summation of x, it can be x bar, y minus expectation of respective y divided by standard deviation of y less than, it will follow the normal 0, 1. Okay, someone had doubt about this 615, right?
Yes, sir. Still, I could not get. Could you please?
Okay, let me. Okay, what about, tell me, if I am saying, let's say, a equal to, suppose I'm saying a equal to b, for example. Okay. If I will do a minus 2, this is same as b minus 2. Yes or no?
Yes, sir.
Correct. Instead of the sign of equality, if I am saying a is less than b, then if I will do a minus 2, this will be less than b minus 2.
Yes, sir.
Correct. The same thing I'm doing here. I'm saying probability x bar less than 615. So this will
is
be
as per statement, sir.
This is what?
No, first, probability of x bar less than 615. This
Correct.
is as per the statement of the question.
Correct. If I will
Okay,
subtract something on the left hand side, then I have to subtract same thing on right hand side.
For balancing the inequality.
Then similarly, standard deviation of x bar, I'm dividing on left hand, then I have to divide on the right hand side also. Is it clear now?
Yes, sir.
Yes. No? Fine. Yeah. Okay. So I think math session is started.
So they can hear the recording, na? This will be available as recording also.
Yeah, it will be available on recording also, and you can find on YouTube as well. Okay, so anyway, the things we have covered more or less. Okay, more or less, I think almost we have covered. CLT is the last topic for from the week 8. As quiz to exam point of view, this last question we can do if you are interested.
Yes, yes.
Any question expected from gamma beta distribution?
No. See. Gamma beta is just for your like just an intro about. See, the thing you have seen, normal distribution, exponential distribution, and all, right? Correct. So gamma is just another form of I think, if I can remember correctly, if you change the parameter of exponential distribution, right? Something I'm not able to recall right now.
Could you take an example from that also, sir?
Okay, 1 minute. Then you will get the form of gamma distribution, beta distribution. So those gamma distribution and beta distribution we will use mainly during the Bayesian estimation, when we will study the topic of parameter estimation. So gamma beta is not important for this quiz 2 point of view. Okay, so that's why we will not discuss in today's session. Okay, we'll discuss more on when week 9 and all we will start. Okay, so as question point of view, still CLT is fine. Okay, CLT, MGF, peak loss, large number, you have to just focus on this. Okay.
Okay, sir.
Yeah. So let's do this question. The number of accidents in a certain city is modeled by Poisson random variable with an average rate of 9 accidents per day. So what are the given to us? So question says we have given X is what is the number of
Which
accidents.
question, son? Which question?
So it's the activity 8.2. Sorry, 8.4.
Okay.
It's 8.2 or 8.4. 8.2. Okay, it's 8.2. So number of accident, okay, in a city, certain city. So this is something it's follows. It's given that it follows Poisson distribution with rate 9. So lambda is 9, right? Now, what are the question carefully? Suppose that number of accident on different days are independent. That means there is some exercise. These exercise are independent. Yes or no? Just write the things what are given. Use the central limit theorem to find the probability that there will be more than 3,300 accidents in a certain year. Assume there are 365 days in a year. So what do you mean by this case? 3,300 accidents in a certain year?
Lower bound, no.
Y greater than 3,000, 3300.
What is the Y here then?
X1 plus X2 plus X3 till X365.
Correct. So, yeah, very good. Actually, we are talking about in a year. So these xi you can see it's the independence. I'm talking about x1, x2. I mean, a number of accident first day, second day up to 365 days. So here I'm talking about y is nothing but x1 plus x2 up to x365. So question is, what is the probability that it will be a probability that there will be more than 3,300 accident in a year? That means y is greater than 3,300. So far it is clear? Okay. Yes or no? So what is the next step? I have to convert in standard normal. So that means I will say probability that y minus expectation of y divided by standard deviation of y. It should be greater than 3,300 minus expectation of y divided by standard deviation of y. Correct? Now
Yes,
tell
sir.
me, what is the expectation of each exercise here? Okay, let me do here. So we know
1 by
exercise is Poisson distribution with 9. So each exercise is 9 and variance of exercise also 9, because in case of Poisson distribution, expectation and variances are same, right? So what will the expectation of y? It will be expectation of x1 plus up to x365. That means expectation of x1 plus up to expectation of x365. That means I can simply say 9 into 365 or not.
Yes, sir.
Correct. So what is the value of 9 into 365? 3,285, right? Okay. So what is the variance of y? It will be again variance of x1 plus up to variance of x365, which is again 9 into 365, right? Which is 3,285. So what is the square root of this? Because anyway we have to calculate the standard deviation of y, which is nothing but square root of 3,285. Anyone can calculate this?
$57.31.
57.31, right? Okay. So now I can simply calculate probability that y greater than 3,300. So probability y minus expectation of y divided by standard deviation of y greater than 3,300. What is the expectation? It's the 3,285. What is the standard deviation? 57.31. It will be probability. Now it will be z greater or equal to. So difference of this 3,300 minus 3,285 is nothing but 15 divided by 57.315. So how much is coming? I think it should be
2617.
2617. Okay. So now since fz is something defined as probability z, so I can simply do 1 minus probability z lesser than equal to, correct? So this is nothing but 1 minus fz of 0.2617. So this value will be given in your question paper. I think it should be given in the, yeah. So you can see fg 0.2617 is given as 0.603. So you can simply do 1 minus 0.603, which is nothing but I mean you need to just subtract 1 minus 0.603, which is nothing but 0.397. Is this clear? So you have to just identify and you have to calculate the expectation of your y and variance of standard deviation of y. For your simplicity, you can calculate variance, then you can take the square root of, then you can simply convert in standard normal, then you will get. Okay.
Sir, why we are minusing with 1?
Minusing with 1?
Yeah, we are minus 1 minus p of z.
Okay,
F
okay.
of z.
So actually that fz value is, okay, how will you define your CDF of fz? This fz, how it
Less
is
than
defined?
equal to.
Actually, fz of any z is nothing but probability z less than or equal to z, right? In this case, you
Yes.
can see it's a greater than sign, right? So we can do 1
Yes.
minus probability. Okay. In the previous question, if you see, initially we had less than sign, right? X, where it went? Yeah, it was less than already. So I can simply direct write fg of 1.5. Okay.
Okay, sir. Got it.
So that's all from my end. Okay, so so just attempt the mock. It will help you to understand the pattern and difficulty level of the upcoming quiz. Okay, so that's all from my end. Okay, so hopefully mock session will be taken by some other instructor. So thanks all. Hope you got the point. All the very best for exam. Okay.
Thank you, sir. Thank you so
Thank
much.
you, sir.
Thank you, sir.
Thank you. Okay, I
Thank
will
you,
upload
sir.
this
Thank
PDF
you, sir.
under
Yes,
supplementary
yes.
content. Okay. Yeah.
Yes.
Oh, fine.
The
Thank
other
you.
one is already done, huh? 5 and 6
5
chapters.
and 6, yeah, it's already done.
I'll go through it. Thank you
Oh,
so
yeah.
much.
Thank you. Thank you. Bye.
Thanks.
Bye.